In question number 31, when the base current in a transistor is changed from 30 microampere to 80 microampere, obviously when we change the base current, the collector current will change, and that current changes from 1 milliampere to 3.5 milliampere. Find the current gain beta. So the problem is simple, but I wanted to explain few things what happens in a transistor circuit. There are not very good materials on internet about the transistor and these things like this. So this is a transistor, and typically this is connected to some voltage. We call it, let's say, VCC or something. And then this is, let's say, in this base of this this is the base of this transistor, this is collector, this is emitter. When you change the current, the voltage on this, so because of that voltage, there will be some current flow from the base to emitter, and we can measure this current if you apply an ammeter. For example, if I use an ammeter here, we can find the change in the current, and we call it the change, the delta IB. If you even slightly change this current, increase it slightly, the channel between the collector and the emitter gets wide, and there's a huge inrush current, a much better amplification, much better magnitude of change in the collector to emitter, and we call it delta IC. And the ratio of these two, change in the collector current to the change in the base current, is called the beta. And we are given that this collector current changes from 1 ampere to 3.5 ampere. So the change will be 3.5 minus 1 milliampere. And the ratio of the change in the base current, he says that it is increased from 30 microampere to 80 microampere. So delta IB is 80 minus 30 microampere. So 3.5 minus 1 is 2.5 into 10 to the power 3. We change milliampere to microampere to make the two units same. So this is 10 to the power 3 microampere. Micro cancels. This is 2.5 into 10 to the power 3, or 2500 divided by 50, which is 250 by 5, or beta is 50. So that is the answer. Beta is nothing but the ratio of the change in collector current with respect to the base current. If you have if you want a amplifier with much higher gain, choose the beta that has a higher value. So let's move on to the question number 33, because this was a simple question, so I have done both the questions in one video. So let's move on to the question number 32. The lead resistor of 2 kilo ohm is connected to the collector branch of an amplifier circuit. I will keep on showing as whatever it says in a circuit diagram. So this is what it's saying. This is the transistor, and this is collector, this is emitter, this is base. It says that the lead resistor of the collector is connected to a 2 kilo ohm resistor. This is what it says. Let's read on what else is there. The load resistor of 2 kilo ohm, this is the load resistor, is connected to the collector branch of the amplifier circuit using a transistor in the common emitter mode. So in the common emitter mode, we have made this base and the emitter are common. If the input current is changed by 50 microampere, and here the change, the current in this branch, in this base emitter, is increased the current gain is 50. The input resistance of the transistor is 0.5 kilo ohm. The beta is 50. That means for every change in one unit change in the base current, there will be 50 times change in the collector current, and the input if the input current is changed by 50 microampere, if you change input current by 50 microampere, multiply that by 50 to get the change in the collector current. So that is what the meaning of the beta is. by what amount does the output voltage change? We need to find out. If I change it by 50, delta IB is 50 microampere, what will be the change in the output voltage? It is asking about the change in the output voltage. So first we will find from this beta and the change in the input current, the change in the collector current. And for this, we have this formula which gives the change in the collector current with respect to the base current. So this is here, beta is delta IC by delta IB, and we are given that. First let's find out what will be the change in the current, and from the change in the current we will try to find out the change in the voltage. So that gives the change in the delta IC, the change delta IC, which is the collector current change, will be given by 50 multiplied by 50 microampere. 50 into 50 is 2500, or if you remove micro we get milli, 2.5 milliampere. Now the change in the collector current, if this is tied to some voltage, there will be some voltage drop across this output resistor, and that will be given by this resistor R multiplied by delta IC, and the change in that current is 2.5 millivolt. The change in the voltage across this resistor will be resistance multiplied with the change in the current, or 2K, which we have given that we have connected a 2K resistor on the collector. That will be 2K multiplied by 2.5 milliampere, or 25 into 2 is 50. K and milli, they cancel each other. We have 2.5 into 2 is 5 volt. So there will be a change of 5 volt, change of 5 volts across this resistor with this much of change, 50 microampere change in the base current. So let's move on to the part B of this question. Part B asks, right here, by what amount does the output, okay, then we have done that. By what amount does the input voltage change? Now the input voltage change, let's go to the figure again. There is a resistor at the base of 0.5 kilo ohm, and then there is a current flowing through this resistor, and that changes. The voltage across this resistor will also change. So that is simple to find out. The resistance multiplied by the change in the current across this capacitor, or delta VB is equal to delta I into R. Delta I we are given 50 microampere and R is 0.5 kilo ohm. Kilo and micro cancel to make milli, and 50 into 0.5 is 25. So the change in the voltage across this base resistor is 25 millivolt. And in the last part we are asked, let's say part C, what is the power gain? So the power gain will be, in this, look at this circuit, in this resistor there is some change in the current and there is some change in the voltage. Multiply these two changes and you get the power change. And the same thing you do it here. In the input side, there is a change in the voltage, there is a change in the current. Multiply these two things, you get a change in the power, input power. So the power gain will be output power change divided by input power gain, input power change. The output power change is delta V out multiplied by delta I out. Input power change will be delta V in multiplied by delta I in. Now delta V out we calculated in part A as 5 volt. The change in the output voltage is 5 volt, and we know that the change in the input current, as part of this part A question, we know that the change in the output collector current was 2.5 milliampere. So we multiply 5 multiplied by 2.5 milliampere. This is a change in the output power. And the input side, we were first given the delta I in was 50 microampere, and the change across the voltage in that resistor we calculated in part B as 25 millivolt. This is 25 millivolt. So the power gain will be the ratio of these two. Milli cancels here, and 5 into 2.5 is 12.5. 12.5 here, and then 25 into 50 is 1250, and micro goes up, becomes 10 to the power 4. 12.5 and 1250, this becomes 100. 10 to the power 6 divided by 100 is 10 to the power 4. So this is the power gain.